This lesson has been developed in the framework of SCILED project.
Module 1, Footwear Performance and Comfort. Unit 2, Mechanical Comfort and Footwear Performance.
Lesson 2.4. Cushioning and Shock Absorption. This lesson is structured as following. Definition. Concepts and theory. Role of footwear in cushioning and shock absorption. Comfort requirements addressing cushioning and shock absorption. Parameters. Innovative solutions on cushioning and shock absorption.
Definition. Concepts and theory. Cushioning is the property of materials to absorb and to dissipate both the impact and push-off loads that occur at every step during walking or running. Shoe cushioning protects the foot and the body against harmful effect of repetitive high-load impacts and stress injuries. It is not a measure of how soft a shoe is, but rather a measure of how long it provides shock absorption and dissipates the ground reaction force over the entire lifetime of the shoe.
Shock absorption is defined as the ability of a body or system to dissipate kinetic energy in another type of energy. The shock absorbers could dissipate kinetic energy into thermal energy and/or plastic or elastic energy. The function of a shock absorber is to receive, absorb and mitigate a force, either because it has been dispersed or because the energy has been transformed in such a way that the initial force has become lower. The better the absorption of the initial force, the lower the force received on the end point.
During the phase of contact with the ground, the center of mass, com, of the body decelerates more or less rapidly, resulting in forces that propagate through the entire musculoskeletal system. Although the human body is prepared to dissipate these forces and mitigate its effects thanks to the layer of fat that is under the heel, a highly effective shock-absorbing system is necessary. Many people suffer from back problems, as well as problems in ankles, joints, knees and hips that may be caused or aggravated due to poor shock absorption of footwear.
When starting a step, the part of the foot that first makes contact with the ground is the heel. In a matter of thousandths of a second, forces of up to 50 kilos are produced, which give rise to a vibration along the body up to the head, also known as the heel strike. Horizontal and vertical components of forces acting on foot, H, and ground reaction forces, G, during push-off and heel strike are presented in figure above.
Role of footwear in cushioning. The shoe components responsible for cushioning are sole, insole, and heel pad. Their role is to protect the foot against the effect of repetitive high-load impacts and stress injuries. The use of cushion footwear components reduce ground reaction force peak impact by 6.8%, ground reaction force loading rate by 8.3%, peak tibial acceleration by 15.8%.
The most important features of bottom assembly are shape, material and its thickness. A properly chosen material could increase the capacity to absorb energy during loading and it could decrease the peak pressure about 12%, comparing to a rigid material. According to Carlson J.M., 2006, in case of rigid materials, having a very firm layer, Figure 6, Case A, the distribution of the load is limited and the normal load per unit area is high. A soft layer decreases the normal load component per unit area, comparing with a rigid layer, as it is presented in Case B. A cushion material having a gel layer that corresponds to anatomical needs of the foot could create bulge spreading of the load over a larger area, such as in Case C.
The gait analysis demonstrates that long-distance walking without good shock absorbers could produce significant reductions in stance time, vertical ground reaction force and ankle dorsiflexion angle. The components of bottom assembly responsible for shock absorption are outsole and heel, midsole, insole and heel pad. The outsole grips to different grounds. In the propulsive phase, when there is no contact with the ground, the outsole helps to facilitate the impulse exerted by the foot. The midsole is made up from compressible materials to help the damping effect, cellular polyurethane, microporous EVA, gel-like materials, air bladders, etc. Heel pads and silicone insoles with good shock absorption properties are usually used to reduce the strain of plantar muscles and to improve gait parameters.
The capability of shoe to attenuate the impact during the gait cycle phases is influenced by several factors. Mechanical properties of the shock-absorbing material, thickness, measured in m, hardness, measured with durometer in A-Shores degrees, density, measured in G/cm3, elastic modulus, measured in MPa. Chemical composition of the material. Position and area of shock-absorbing material within the footwear. Geometry of the footwear component and outsole grid.
Testing. Comfort requirements and parameters. Shock absorption test consists of the free fall of a plunger of a given mass, with the surface of the base in the form of a spherical cap, from a pre-established height, on the surface of the shoe, in the heel and or forepart areas, or on the sample to be tested. The measuring conditions during the test: plunger mass of 8.5 kg and fall height of 50 mm, reproduced the speed of impact of a man's heel on the ground when running. It is known that these are impact energy conditions higher than those that occur in more frequent situations in life, such as walking. In this sense, biomechanical studies are being conducted with people and different types of footwear to establish impact conditions in these situations.
During the impact, the following parameters are determined. The maximum deceleration is one of the key parameters related to the damping capacity of a material. Good shock absorption implies a low deceleration value. For example, sports shoes for jumping or running require a lower maximum deceleration than in the case of casual footwear. The penetration is the maximum compression of the sample under impact. The value of this parameter should not be too high to avoid feeling a lack of stability in the tread. Percentage of energy returned in the first rebound is the proportion of energy that returns after impact, calculated from the height of the rebound of the mass. Materials with great elasticity provide a good return of energy, while in dead or non-elastic materials there is simply a small jump. In footwear, it is advisable to obtain a high return of energy.
The energy absorption test is carried out on the heel area of the footwear, but, unlike the shock absorption test, the dampening properties are measured with lower deformation speed conditions, so the results of both tests are complementary. The energy absorbed by the sample, in joules, is calculated by means of the integral of the force deformation curve recorded. This value will depend essentially on the ability of the heel dampening system to deform under compression, which in turn is directly related to the hardness of the materials that comprise it. Also, the thickness of the heel is essential in this test. If it is very thin, it will be detrimental to the ability to absorb energy. By way of example, the test requirement for safety footwear is at least 20 J.
Comfort requirements addressing cushioning and shock absorption. Parameters. The fatigue test in the heel of the footwear consists of subjecting set area to a determined number of cycles of dynamic compression with a frequency of 1 cycles, using the back part of a last, with a specified load, as shown in the pictures. The variation of thickness in the center of the heel is determined as well as the variations of shock absorption and energy absorption before and after the fatigue test. This way it is possible to estimate the useful life of the footwear in terms of dampening protection.
Innovative solutions on cushioning and shock absorption. There are multiple and varied solutions on the market. In general, most of the developments are based either on the geometry of the shock absorbing system, normally placed in the heel of the footwear, or on improved shock absorption characteristics of the materials, or a combination of both aspects.
The new technology created by Saucony provides 20% more cushioning than standard midsole. It has the features and efficiency to keep more durable cushioning for less weight. The 3D printed midsole with improved support and cushioning properties was developed by Adidas and it was integrated in the Futurecraft 4D model. The support is provided by increased mesh density, while the cushioning properties is given by decreased density of the bottom assembly.
Enco running shoes include an innovative system consisting of 2 interchangeable energy absorbers adapted to the consumer way. The energy received during the heel strike is absorbed and stored by the shoes and gave back when the heel is lifted off the ground again. The Enco technology incorporates the following features: exclusive patented sole, integral support straps, light and breathable fabric upper, interchangeable studs, switcher for walking or running,